So Becca, what are you writing down over there, Becca?
I heard 10 squared plus 12 squared equals c squared.
Good. Because that's the what, Becca?
Wait, what?
Because this is our what? What theorem is this?
Oh, the Pythagorean theorem.
Good. So if we have a right triangle, which we do, and we know two of the three sides, which we do, then we can do the Pythagorean theorem. What's been new the last day or two is some of these you're given a right triangle, but you're only given one of the sides, and then this option isn't available to us. But if we do have two of the three sides, then this is still your best bet. It's what you're most familiar with. So she did 10 squared plus 12 squared equals c squared. Add those together. I don't know if what I told you with rounding was the hundredth still. Yeah, to the nearest hundredth. So we're going to go to the second decimal spot. So to get rid of our square, you're going to take the square root of both sides. This initially does give you, remember, a plus, positive, and a negative solution from way back in the day, last semester. So you have your little plus minus initially, and then we all get 15.62. Now, when we're talking about the length of a triangle, however, we can't have a negative 15.62 as a length. So that's why we then pretty much just ignore the positive and negative and know that that length has to always be positive, and then that's the length of that side. Okay? To find the angles, however, this is definitely new. The only way you're going to be able to do this, at least the first one, is with the idea of SOHCAHTOA, the right triangle trick stuff that we've been learning here over the last couple of class periods. It's totally up to you which angle you want to solve for. So, Gavin, which one do you want to solve for, x or z?
X.
All right, so Gavin says we're going to solve for x. So what we're going to do is come up here to x, and you have a world of possibilities available to you right now, because we know all three sides of that triangle. So if you look at angle x, you could do sine, cosine, or tangent for angle x. It's really whichever one you prefer. So take 30 seconds and see if you could set up one of those options. Because I could do it, but it might not have been your first thought, because there's really three different routes we could take here. All right, so here's what I mean by we have a bunch of different options. It's the whole idea of SOHCAHTOA. So if we do the first three letters, we can do the sine of this angle as long as we use the correct sides, the opposite and the hypotenuse. You could do the cosine of that angle, which is the adjacent over the hypotenuse. You can do the tangent of that angle, which should be the opposite over the adjacent. All right, did anybody do sine? All right, Cam, what'd you use for sine?
So I looked at the options as well.
Okay.
And then the hypotenuse is 6.
Good. So if you did sine, you should have this. Then we'll solve this here in a moment. We'll review on how we solve this. Anybody do cosine? Let me do cosine. Anybody do tangents? My personal favorite. Yes, Vicky, what do you put for tangent? Good. So tangent is the opposite side. So here is the opposite side. So she put 12 over 10, because 10 is the adjacent side that is not your hypotenuse. All right. Nobody did cosine. Let's go ahead and set that up just so we could have. If this is angle x, the cosine is the adjacent side, which is the 10. And then over the hypotenuse, which is 15.62. All three of those are going to give the exact same degree measure for angle x. Okay? So whichever one you are now solving for, so if you have the sine, cosine, or the tangent, you just have to plug this in correctly. What we are now trying to do is isolate this variable right here. So if we want to isolate that variable, we need to get rid of the sine in this case. If you want to get this variable, you need to get rid of cosine. Here you need to get rid of tangent. So whichever version you have, The way we get rid of that is with that inverse sign. That little sign to the -1 option. So what we do is we do that to both sides. You don't necessarily have to show this, but when we do the little sign of a -1 to this side, that's why this is going to cancel. My pen will work. Leaving you just X. Then on the other side, we have to do the same exact thing. So you have to do the inverse sign, that second sign key on the calculator, of 12 over 15.62, if you did that option. If you did the cosine, you're going to do the inverse cosine of 10 over 15.62. If you did the tangent, you're going to do the inverse tangent of 12 over 10. All three of those should give us the same angle. All right, what did you get, Cam?
I got 50.
50.19. So is there like 50.2 then if we round to the 100th?
Yeah.
Okay. So we should all get 50.2 degrees. There might be a really, really small little error, not that I would penalize you for it. Since we did this Pythagorean theorem and we rounded this off a little bit, could be just a little bit off when we get to the hundredths or the thousandths decimal place, but it should be very, very minor. You should be pretty much right at 50.2, regardless of which option you picked. All right. If we know this is then 50.2, you could use the SOHCAHTOA again to figure out the other angle, but you're being silly if you do. Like, right, we still need this angle. So we could set up another one of these here. But don't we know the whole 180 of a triangle? We now know two of those three. So we do 180 minus 90 minus 50.2. That's got to be what angle Z is then going to equal. All right, that was what, Kim?
39.8.
Good. That's 39.8 degrees. And then we have everything we need. So angle X was 50.2 degrees. This was 39.8 degrees. And then XZ had a length of 15.62. Okay. All right, for pretty much the exact same thing, you're given two of the three sides. So you're given that this side was 25, this side is 32. So if it were me, I would, figure out what that other side is right away. So let's do that. Find this missing side. I'm going to erase this in about 5 seconds unless somebody says something. Anybody need this to stay on screen? You need it for a little bit? Okay. Maybe I could do it up top here. Yeah, we got some space to work with up here. Oh, Vicky probably can't see that. All right, so with our sides, just like that third one, it's going to be the Pythagorean theorem. What is a little bit different in the third question? You didn't know your hypotenuse, so you were solving for C. In this case, you were given your hypotenuse. So when you set this up, the C definitely has to be that 32 squared. And then the other one, pick either A or B to be your 25. And then we're solving for the one that remains. Okay, this I do. So it's what, 625 plus B squared equals, that one I don't know. 1024. All right, thank you. Subtract your 625 over. Is that 399? Yeah, 399. Take our square root of both sides. That's got to be awfully close to 20, right? 19 something ish.
Yeah, 19.97.
It rounds to 20 because it's like 13.99. Okay, so pretty much right at 20 for the length of B.
Oh, we should round it up.
What does that give us exactly? If you're rounding to the nearest hundredth, my guess is because the square root of 400 is 20. So when we have the square root of 399, I'm asking you to round to the hundredth place.
Yeah.
So let me see what these.
974. So we're going to 19.
Yeah, I suppose because that 4 technically is just a 4. Yes, I suppose that is 19.97 because we want to round to the second decimal place. So we want this to be where we round to. The number after that was a 4. If not, then we would have had to round up a whole bunch of times to get to 20. But we'll write that as 19.97 because that's what I had put in the directions. All right, just so we have a common angle now. Has anybody done this yet? Find an angle. Which angle did you do, Cam?
I chose T.
Okay, so Cam chose angle T. So just so we're kind of all doing it at the same time, and if you've already done it, you're understanding it, then knock it out. Feel free. Find angle T. We had all, SOHCAHTOA down here. You really can use any of these three. Again, we know all three sides, so all three of these sine, cosine, and tangent options are available to you. Whichever one you feel more comfortable with, you see easiest, is completely fine. All right, then plug it in, and then regardless of what you pick, so I'm going to call on somebody, we'll either do sine, cosine, or tangent. If you pick the other one, doesn't necessarily mean you're wrong. We ultimately want to see, when we write down what the degree measure of angle 20 is right here, regardless of which option you pick, they should all give us the same exact answer. All right, so Cam, you had your hand up. What did you set up?
I chose sine.
All right, so Cam likes the sine, I think. So you're going to say the sine of what?
Angle T.
Good. So the sine of this angle here, which is T, is equivalent to what?
19.97. Divided by 32.
Good. He did the opposite side over the hypotenuse. That's what sine means. And then to solve this, you do what?
I put the second key. What's that called? The -1.
The inverse sign.
The inverse.
Good. And then he did the inverse sign of that fraction on the calculator. I really don't know what this is, so let's see if we all got the same thing. What would this give us?
38.61.
Okay, we all getting 38.6-ish degrees, regardless of which option you picked. So then angle T is 38.61 degrees. Now again, we rounded this one. So if you use the 32 and the 25, which would have been a cosine, it might be off just a little bit, but it should be very, very, very small in terms of the different decimals that we're going to get here. All right, and then once we know that's 38.61, now it's the old idea. Actually, the very first thing we ever did with geometry 2 modules ago. We have 180 total. What did this last angle have to be, Kim?
51.39.
Good, 51.39 degrees. All right. All right, feeling good with this? We understanding? All right, then go to the homework. So the homework is just going to be the next page, just 1 through whatever that is, 1 through 12. So this will be your homework, 1 through 12. You're not going to do all 29. That won't be that mean. Okay. Let me see if there's any that I prefer.
Number 9. Is it on there?
Number 9.
It's gone. At least on camera.
This one right here.
Yeah. And then numbers. Or actually, what's number 9? Oh, number 9 got pushed off. And they only have half of it on the first page.
Oh, then they don't have anything after that?
Yeah, there's no more.
Wow, that is really weird. Your all look like that? You know what? He got a new one. Remember he grabbed it?
Yeah, I grabbed it exactly this one.
Yeah. So 1 through 12. Everybody else have 1 through 12 on this page?
Yeah, everybody else has it.
Okay. Do you have a next page, Cam, with 10, 11, and 12?
Yeah, he has that.
Okay, so just do what you have. If you can't do number 9, that's fine. All right, we just did some angles. Let's do go to let me set one up. Cosine. All right, I want you to do number 5. 5 is one that I want to see if we could solve number 5. So go down to number 5 here. Solve for that x. All we want is x. Yeah. All right. Now with number 5, you really only have one option. The previous questions, we have a lot of options because you knew all the sides. Or you could do the Pythagorean theorem because you knew 2 of the 3 sides. Here, everybody has to be setting up well, I guess you don't, but I would think most of us are going to set up something similar. And that is the idea that if this is the angle that we know, this is what we would call our reference angle. We're looking at the other sides that we're looking for. Then clearly, if this is the angle that you're given to work with and you're solving for x, we have to include x. So if I now ask you, with 51 degrees as our reference angle, if I ask you if x is the opposite, the adjacent, or the hypotenuse, x is which side on this triangle if this is our reference angle? The opposite side of 51, the adjacent side of 51, or the hypotenuse? What does it have to be? That's the adjacent side. So we have to take into account when we start talking SOHCAHTOA, then it does us no good to consider sine right now because it doesn't include the adjacent side at all. But if we look at cosine, we have an adjacent. If we look at tangent, you have an adjacent. So if we're going to solve for x with 51, we have to use one that has the adjacent side. 46.1, the other side that we know, we already said this is the adjacent. So is 46.1 the opposite side or the hypotenuse? It's the opposite. So if we said this was the adjacent side, and we're now saying this is the opposite side, tells us we have to set up a tangent in order for us to use what we were given. So we would set up the tangent of 51 degrees is the opposite side of 46.1 divided by the adjacent side of x. And here's why I want, other than setting it up, making sure we understood we have to now make a decision between these 3, that all 3 of them don't work. Now that we've made that decision, I wanted to see if we can solve this equation, because this is the one where we have our x in our denominator. We never really want to do that for any equation to solve for it, so we always want to get that out of there. So since we would be dividing by x, we want to multiply by x to the right-hand side, so we no longer have that in the denominator. But if I multiply by x on the right-hand side, I need to multiply the other side by x as well. And then how do we undo multiplication, even though it looks weird? We undo multiplication through what operation? Divide. So we now, if I'm going to get x by itself, I want to get rid of this tangent of 51 by dividing it over. So what you're now plugging into your calculator, once these cancel, x should equal, this is what we are now plugging into our calculator, the 46.1 divided by the tangent of 51. That then should give us this side for x. All right. So, all right, I'll get 37.33. All right, that should be 37 point, and I wanted the hundredth again, 0.33. So that's got to be the length of that side right there. All right. So if you're not given as much information, you now need to make a decision on which one you're going to be using. All right. So that's your homework. You're going to do 1 through 12, and then a couple of things. If you guys have your Chromebooks, you're going to need them out. So 2 things. Tomorrow morning is the senior signing breakfast for seniors who are signing in college to play a sport. And it's in the building, and Coach Kubowitz and I both have multiple girls who are signing to go play sports in college, and we have to be here. Neither one of us live particularly close to school, so we're not real sure we're going to be back by first period. So what I'm going to be doing tomorrow, just so we're clear on this, it's going to be underneath the quiz category, just because that's how I can have you do something. So this thing will open. I am going to leave you a little quiz. So I haven't made it yet. I was just trying to figure out what we were going to do, Mr. Kubowitz and I, before class, and I think that's kind of what we have led to. But I'll make it. It'll have tomorrow's date, so it'll say 4/28. You'll have all day to do that. If you want to do it at this period, do it at this period. All right, from that 10 to 10:35 time frame that you would normally meet for class, whatever that time is. But just do that. All right, we were supposed to have something. We can do something asynchronous on Wednesdays anyway. That's always an option. So we're going to set that up for tomorrow. I'll put it out on Canvas. I'll send a remind message. I'll try to remind you. But just get that done sometime tomorrow. It's just going to be some of these problems. It's probably going to be good feedback for us anyway to see how you're doing. But we won't meet in class tomorrow. There's a reasonable chance that neither one of us will be home by first period tomorrow. Okay, so that's tomorrow.
What will you enjoy?
What's that?
What will you enjoy?
Usually they give you a really nice breakfast at this. I mean, like pancakes, French toast, sausages. Like, it's fantastic. But with COVID, we don't even have that to look forward to tomorrow, unfortunately. So, yeah, they're not putting any food out, which sucks. Yeah, usually it's quite the spread. Yeah. But that's what you're going to do tomorrow. What you're going to do today, if you notice, there is one with today's date on here. So as soon as I click this little guy, which I'm going to click right now, you should now see this. So if you don't see it right away underneath your quizzes, just hit refresh. And I want to see where we're at on 2 little ideas here. So it's just a 2-question quiz. Once you start, you'll have 5 minutes to do it. We've got 9 minutes left in class. So if you're pulling it out, you've got a little bit of time to do this. And then I just want to see 2 things. If we're understanding how to set these things up, that's one of the questions. And do we know how to plug some of this stuff into the calculator? That is the other question. So when you are done, here's the one that you're finding. When you are done, if you are at home, you are free to check out. In school, just hang tight till everybody is done. And then we'll see how we do. All right. And then again, tomorrow you are on your own. I will have another one of these. It'll be a homework assignment. It won't count as a quiz. It'll say 4/28. It should take you 15, 20 minutes. And then that'll be it. Just showing you your score also, right? You can see how we did. Jenna, did it show you your score? Okay. Kind of wanted us to see. And the decimal, make sure you round correctly because it's got to match exactly what I would have put in there to the second decimal.